In the previous episode, we discussed some basics of bones. Today, let's start considering how they influence models, which brings us to armature deformation. Here, I have prepared a model and an armature. The armature has been subdivided accordingly. First, let's select the model and then the armature in object mode, then press Ctrl+P and choose with automatic weights. Next, select the armature and enter pose mode. You can press Z to switch to wireframe view. If you rotate the bones now, you'll see the model reacting accordingly. This is because after performing the armature deformation, an armature modifier is added to the model. By the way, if you want to select the model in pose mode, you can simply go to the Edit section to uncheck Lock Object Modes. This allows you to select the model in pose mode. An armature modifier will be added after skinning. The object corresponds to the name of the armature up here. If we delete this modifier, or disable its visibility, or remove the armature from the object section here, the model will no longer be affected by the armature. Moving on to the vertex groups in the Mesh Data panel, you'll find corresponding vertex groups added to the model after armature deformation. These groups are named after the bones. If you modify or delete one of these vertex groups, the corresponding bone will no longer affect the model when edited. Let's undo the operation. Now, let's discuss weight painting. Press Z to switch to solid mode. We select the model, then press Ctrl+Tab to switch to weight paint mode. Here, you can check and adjust the influence range of each vertex group. You can select each vertex group to see its influence range. Using the brush tool here, you can modify the weights of the bones. Weight modification will change how the bones affect the model. Let's undo the operation. Hold the Control key and press the Tab key to enter weight paint mode. When performing weight painting, you can adjust the pose of the bones as per your needs and then do it based on the desired pose. In weight paint mode, the strength of the weights ranges from blue to red, indicating low to high influence, respectively. Of course, sometimes there are weights on the model, but the influence values are too minimal to distinguish. To address this, I select Active in the Viewport Overlays menu. This way, the areas without weight influence will appear pure black, while the areas with minimal weight influence will appear blue. Then, you can increase or decrease the weights according to your needs. We won't go into detail about weight painting mode here. Now we press Ctrl+Tab to return to object mode. Hide the model and select the bones. Next, let's take a look at the common functions of bones in the data panel. First is the skeleton. The default option is pose position. The other option, rest position, allows for quickly switching the armature back to its initial pose, showing all bones status in edit mode. We select bones and go back to pose mode. Now, we can see their transformation still exists, but we cannot manipulate the bones in this state. Let's click on pose position again. Now the bones return to the adjusted pose. Before moving on to the skeleton layers, let's select all bones, press Alt+R to reset the rotation values to default. If needed, you can press Alt+G to reset the location values or press Alt+S to reset the scaling values to their initial state. Now we come to the skeleton layers. Each layer can contain different types of bones. When rigging, we may have skinned bones, auxiliary bones, and bones used as controllers, and placing these different types of bones in different layers makes management easier. In the 3D view, you can select bones and press M to adjust which layer they belong to. A small dot in a layer button indicates the presence of bones in that layer. If there's no dot, it means there are no bones in that layer. Now, let's introduce bone groups. The bone group option is used to group multiple bones and allows us to assign a distinct color to each group. During rigging, bones of the same type are often adjusted to the same color, so that it's easy to distinguish between different types of bones. Let's select one or more bones, then use the Add button to add a bone group. Then, you can click on the Assign button to assign the selected bones to the current bone group. Now, you can click on the Select button to select all bones in the current bone group. You can also remove some bones from a bone group. This way, we will only select the bones that exist on this layer. The options in the Group section are used to set a specific color of all bones in a bone group. You can choose from preset colors. This makes it possible to distinguish different bone types by color. Next, let's look at the viewport display. The options here determine how bones are displayed in the 3D view. The first option allows us to select the shapes bones appear in, which defaults to octahedral, just like the bones in the current viewport. Let's adjust it to stick. Now, the shape of the bones in the viewport is changed to stick-like. In this display mode, it is convenient to adjust the position of bones when creating bones, such as spines or tails during rigging. Initially, you can create a large bone, then subdivide it. When adjusting the position of the large bone, you can switch to the stick display. Since the head and tail are large in the default display mode, it's not easy to adjust their positions. Next, we switch to bendy bones. Now the appearance of all the bones in the view has changed to cuboids. You can select the bones, then go to the Pose section, hit Transform, and choose Scale B Bone. Then, drag the mouse to scale the bendy bones to your desired effect and confirm by left-clicking. Now you'll notice the selected bone's thickness has changed. We will discuss the specific function of bendy bones later. Other options like envelope and wire in the display section are not commonly used. These are options in the Show section. The Names option displays the names of bones in the view. It's helpful to have a convention of naming the bones during rigging, so that we can use the Names function to find corresponding bones easily. The Shapes option determines whether custom shapes are displayed in the view, which we'll discuss later. The Group Colors option allows us to set custom colors for bones and bone groups, as mentioned earlier. The In Front option displays the armature in front of other objects. Let's display the model and enable In Front. Now, the bones are displayed in front of the object, which is easier for us to select bones. The Axis section displays the axis of each bone in the view. We uncheck the Names option for now. The position value determines the position of the axis displayed on the bone. Adjusting the value to 0 displays the axis at the head of the bone, while adjusting the value to 1 displays it at the tail. Next, let's discuss the common options and settings in the bone panel. This panel displays the properties of the selected bone. The first option is Transform, corresponding to the transformation in the side panel. These two panels display the same values. Next option is Bendy Bones. Before adjusting bendy bone parameters, let's display the bones as bendy bones so our operations are visible. The default value for newly created bendy bone segments is 1. When adjusting the value, we can see the number of bendy bone segments displayed. Increasing the number of bendy bone segments also smooths the model. We select the other two bones and hold the Alt key to increase the segments simultaneously for both bones. Now, you can see the operations on bones bring smoothing effects to the model. Let's set the value of the segments to 1 for all bones by holding the Alt key. Obviously, this operation affects the smoothness of the model. Some parts of it are getting less smooth. This option is useful during rigging to reduce the number of bones while achieving a smooth effect. Next is the Relations option. This displays the name of the selected bone's parent and the bone group it belongs to. As we mentioned before, you can use the left square bracket to switch the parent of the selected bone. Also, we can copy the current bone's name and search it in the outliner, which will show the bone's hierarchical relationship. This is often used during rigging. The next option is Deform. By default, each newly created bone is set to deform, meaning they participate in weight assignment during armature deformation. If we don't want a bone to participate in weight assignment during rigging, we can simply disable its Deform function. After that, the bone will no longer affect the model. You can also select multiple bones. Press Shift+W in the 3D view, choose Deform, and then select Disable here. Rotating the bone now won't affect the model, and vice versa. You can select the bones, press Shift+W, choose Deform to enable the Deform function. Then, these bones will affect the model again. Next is Viewport Display. The Hide option hides the bones in the viewport, corresponding to the visibility button in the outliner. The next one is Custom Shape. This option allows us to select a custom shape for the current bone to replace its appearance in the view, acting as a controller during rigging. Let's give it a go. We switch to Object Mode, create a circle, then switch to Pose Mode. Select the bones you need to replace with this custom shape, and press the Alt key to specify a custom shape for the selected bones collectively. Now, the bone is displayed as a circle, but the circle's orientation is not what I want. There are two ways to adjust it. One is to tweak the parameters below for rotation or scaling to achieve the desired effect. Let's undo that with Ctrl+Z. The other method is to edit the created circle object. Rotating it in object mode won't affect the bone's custom shape. So, we need to enter edit mode with Tab, then press R and X to rotate 90 degrees on the X-axis, or press S to scale if needed. Now, the bone's custom shape is what I want. Please note that modifying the custom shape of bones does not alter the bones themselves. It's just a display method. Of course, directly adjusting the parameters here can achieve the same effect. Likewise, the changes only affect the bone's custom shape and does not affect the bones themselves. Let's return to the data panel. Here, the Shape option toggles whether the custom shape is displayed. That concludes this episode on basic operations on bones.